So what is an inexact differential? Inexact differential have an infinitesimal which is not the differential of an actual function. That is, which cannot be expressed in this form. Exact differential or DC form the inexact differential the example this is not the differential of an actual function. Inexact differential the expression function total differential in EBR. Inexact differentials are denoted with a bar through the D. Differentiation the D. D to the bar DQ. So for example, in thermodynamics, first law of thermodynamics. Let me stop the sharing. In thermodynamics, in a system dq amount of heat the internal energy increases by an amount du, and the system performs some work which is given by d cross w. Sayda aina thermodynamics ta system amada dq haiba amount of heat pisale aduga aduna maram hit to maram oidana system internal energy du haiba amount increase tawgre aduga systems in work work amount dw kore. This expression is the first law of thermodynamics. This is the expression for the first law of thermodynamics in differential form. Matang sida ay baram happy d baram happy ka. So baram happy ka. What is the meaning? It simply means that in a pisali hit say this hit is not an exact differential. This dw is not an exact differential. System in an infinitesimal process from some initial state I final state f of the I f of the the change in internal energy does not actually depend upon the path. It depends only upon the initial point and the final point. But dq habasidi path ki makha pole dw habasisu the actual work done in thermodynamics. This also depends upon path. Aduna see dq dw ko say these are not exact differentials. What is exact differential nattabrina koina bar hapeba. See say no like the half the but to differentiate between exact differential and the inexact differential, we use bar to represent inexact differentials. Thermodynamics, the work done in taking a system from one initial state to a final state, it depends upon the path. Therefore, this dw is not a state function. dq is not a state function. U internal energy is a state function. Aduna magi differential exact differential ni dw exact differential natte dq exact differential natte. Aduna exact differential inexact differential thermodynamics tammi bane yauri bane okay. We can look at another example. Another example say let us come back to screen sharing. Sidasu leireko. Sagido in exact differential. In exact differential, kung sa mamang do hot kibudo. In exact differential, habidi kung sa example ama kung discuss to kibudo. This expression, it cannot be written as the total differential of any function. Such expressions are such differentials are called in exact differentials. Adudagi amuk ekoi thermodynamics ta ekoi na amuk kari amuk thengna bu yage haibada. So stop sharing. Thermodynamics ta ekoi kari amuk thengnei. Hariba in exact differentials in exact differentials ekoi exact differential on thokpa yaba case thengna gura. Technology ko we came across instances where this inexact differential has been converted to an exact differential. So let me share the screen once again. So this is the problem. Problem number 12 is dx equal to cvt dt plus nRT by v dv an exact difference, an exact or inexact differential. Sigisi exact differential la inexact differential la yang aseba. The quantity cvt is simply an arbitrary function of t. In thermodynamics, this cv is nothing but heat capacity at constant volume. Is dx by t an exact differential? Aduna masai haigibada sigisi exact differential oi natraga inexact differential oi haigi haidi koi combine check tabuni haiba sigi dt ki mamang da lariba coefficient se this is like del p by del t whose I would del p by del t adudagi sorry del f by del t, and this is like del f by del v. So the x hierarchy, this is like del x by del t, this is like del x by del v. Aduga magi crossed second derivative to adu follow aduga manabra yengo haibneba. Manaragadi exact differential oiduni, manadragadi exact differential oiduneba. So let us consider this example. So here dx equal to cvt dt plus nRT by v dv. This is the expression. Aduga hangliba question di kaino hangliba question di sigise. Is this an exact differential? Is this an exact differential? Ko mamang do what adumana policy let us assume that this is an exact differential. So an exact differential dx should be written as del x by del t at constant v dt plus del x by del t, sorry, del v at constant t times dv. Sure, you never. Now let us calculate the cross second derivatives. So del x by del t at constant v. Now let us calculate del by del v at constant t. So this is del by del v. What is del x by del t? Del x by del t is this. Del x by del t d cv t dt. Sorry, because this is nothing but cvt. CVT. Here c is a function of only t. V means at constant volume. So here c is a function of only t. Here v means this value is calculated at constant volume. So this is a function of only t, and you are differentiating with respect to v. This should be equal to 0. Next, let us calculate del by del t, del x by del v at constant temperature, constant volume. This is del by del t, del x by del v. What is del x by del v? nRT by v. This is nothing but nR by v. nR by t is differential already nR by v later. So the mixed second derivatives, they are not equal. Anise manadre. Anise manadre then that means this given expression, this given differential is inexact. Inexact differential level. As the exact differential natreva. This is inexact differential. Yarba. Adudi mazi inexact differential ore. Adu orgadi inexact differential amadagi exact differential amada on top yabra. Question this in ever. So let us come back to that. Is this differential an exact or inexact differential? The answer is inexact differential. The quantity CV is simply an arbitrary function of t. Next, is dx by t an exact differential? So dx ki expression है so t है बामन again थो t है बामन t है बड़ी kind of temperature divide out over. तो ये exact differential ताबरा तादा बस. So let us see that. So let us write dx again. Dx is sinica. So let me write it on a new page. Let me write it again on a new page. So dx equal to cv t dt plus nRT by v dv. This is dx. If we divide dx by t, this is equal to cv t by t dt plus so t divide already nr by v dv. Now the next question is this differential an exact differential or not? CGC exact differential money in lower. CGC f of t and v. F of t and v, such a function exists whose differential is given by this expression. And you can know df equal to cvt by t dt plus nr by v dv. F segumba function number exists in khalaji. Let us assume that a function f exists whose differential is given by this expression. This. F df is exact differential my condition it should be expressible as del f by del t at constant volume dt plus del f by del v at constant temperature. This should be expressible as in this form. You compare this and this, del f by del t sitare. Let us calculate the cross second derivatives. So del f by del t at constant v. Now differentiate this again with respect to v by constant temperature. This is equal to del by del v. What is del f by del t? When you compare this and this, del f by del t is given by this expression. Cv t by t. So this is the cv t by t. Here we're calculating the partial derivative with respect to v at constant temperature. So T is a constant, T is a constant. So this term is a constant. So this is 0. Next, let us calculate the second, the second mixed derivative, the other second mixed derivative. So this is del F by del V at constant temperature differentiate with respect to T at constant volume. This is del by del T. What is del F by del V? Del F by del V should be equal to NR by V. So this is NR by V. And this is calculated at constant volume. N is constant, R is constant, V is constant. So this is again 0. So mixed second partial derivative se manarabna this expression, this given expression, this is an exact differential. This is an exact differential. Aduna sigi inexact oiba differentials the exact differential tarakpa yai. Kamai toro tarakpa yai by multiplying by a factor. Adugi multiplication factor to karikawi integration factor. Akoina differential equation tam give do integration factor tam give do if and tam give do aduneva adugi same idea aduneva. So to convert an exact inexact differential to an exact differential, we multiply by an integration factor. So in this particular example, what is the integration factor? The integration factor is 1 by t. In this example, the integration factor is 1 by t. 1 by t is the multiply tarkanda in exact number differential to exact differential integration factor. So in thermodynamics, see dq is an inexact differential. This is an inexact differential. If we consider a reversible process, a high reversible process, dq is if I divide by temperature. This is du by t, d bar w by t. The inexact differential ni, if I divide by t, this is equal to the change in entropy, infinitesimal of the entropy. Aduna, thermodynamics inexact differential inexact differential an integrating factor. The integrating factor is again 1 by t. 1 by t is multiply tarkanda, I get an exact differential. And that exact differential is ds. And what is S? S is the entropy. This is the second law of thermodynamics. Second law of thermodynamics. Inexact differential an integrating factor amana multiply toroga exact differential on be aba case khar legani ko adu itadi exact on bangamagadi adugi aina multiplication factor ru kari kore integration factor kore. Thermodynamics example li kaino the heat the infinitesimal heat flow during a process high process or reversible process whatever aduda aina reversible quasi-static process whatever aduda aina temperature do not divide to. So the heat flow during the reversible quasi-static process, if I divide by T, the expression becomes an exact differential, and it can be written as the differential of the total differential of the entropy function S. Aduna in exact differential on top of thermodynamics idea ado patang sida lotion be are